Hey, and welcome back to Alchemist Camp. This is where we learn Elixir by building things. So last time we made a ridiculous program called Word Count Ultimate Edition, and this time we're going to do something else kind of silly, which is a to-do list. Now, you may be familiar with to-do lists because pretty much everybody who makes a JavaScript framework makes a to-do list for it. Since Elixir is, it's not in the web browser, it's on the back end, we're going to do a command line driven to-do list, which works, but it's a little bit odd to do in 2017. The reason we're going to do it is because it'll be a good chance to play around some more with file processing, and we'll use maps, which we haven't used in any of the previous lessons, and we'll encounter some good stuff along the way. So the file is going to be called minimaltodo.ex, doing a whole one, not a script this time. This time I want to show you something I've done with my editor. If you go to File, assuming you're using Visual Studio Code, although other editors like the IntelliJ based ones and many others can do this. In Preferences, there's something called User Snippets. You enter the language you're using, and these are all snippets that I've written. One that I'm going to show you right now is define module. What this does is this lets me start typing in D module and then autocomplete to all this stuff. So it'll autocomplete to def module, and these numbers that you see are I should say these dollar signs that you see are tab stops. So if I hit tab, it will take me in here, and if I hit tab again, it'll take me in here. And notice this \t, this is a tab stop in the middle of what it expands to. So let me just show you. Type in DMO, which is enough, and then Control Enter, and I hit Enter, and see name was in there by default and it's highlighted. The name of this module is minimal to do, and then I hit tab and it takes me right down to where I want to start typing to make the stuff that goes in the module. Another one that's very similar that is super useful is to make one for define function, which you can see here. Did almost the same thing. Prefix is dfunction. There's definition. Then this is the first tab stop right here. The default value for it is name. The second one is right afterwards inside parentheses that will be highlighted and easy to delete if I don't want any arguments. Third one is right after it, which is good for like a when guard or something like that. And then next I end up going into the function. So I'll show you that. Defun, and I'm going to name this function start, and I actually don't want anything here. I hit tab again, takes me into the middle of the function. You certainly don't have to do this kind of thing with your editor, but if you're a little bit slower of a typist, which I am because I've had some repetitive stress injuries, this can help you quite a bit. You can save a lot of keystrokes and let you get what you need to do that's pretty repetitive done quickly. I mean, it is a computer after all. It's kind of crazy not to use it to automate things. With all that said, let's get on to the project. Since this is a command line version of a to-do list, I think we're going to want to use just the local file system to store our to-dos. So I think the easiest way to do that is with a CSV file, because a CSV is easily read or created from Excel or OpenOffice or Google Docs, and you can read them pretty much without any program at all. Like if you just open it with a text editor, you can usually get an idea what's going on. So I think it's an easy way to go. Let's make a plan for how we're going to do this. Go full screen. I'll bump up the font size a bit. There we go. All right. So the first thing we're going to want to do is ask user for file name. Then we're going to want to open the file and read it. Then we're going to want to parse the data. And the next thing we're going to want to do is ask user for command. The commands are probably going to be, let's see, we're going to want to read the to-dos. Read to-dos. Going to want to be able to add to-dos, delete to-dos, load file, and save file. Come up with any more, that's fine. I'm just putting this up here to get an idea of where we're starting. All right, so first step is we'll make a function to read in a file, just like we've done in the past. And I'll use this shortcut that I showed you. Read file name, and we'll use a case. Actually, let's look at the docs really quick here. I think this could be helpful. So here's the Elixir page, the docs, Elixir standard library, and we'll look at file. There it is, functions and read. So last time we used this read. We used the one that will crash if the file is not there or if you can't open it. This time we're going to use the read without the bang at the end of it that returns a different tuple if it succeeds or fails. Tuples are new to us, so let's have a quick look in IEX. So we'll just call a tuple tup. Tuples can have any kind of data in them. You can mix all sorts of different things as so. Oh, but you do have to use an equal sign if you want to assign one. Okay, so here's a tuple, and this tuple is tuple module, so that's where you're going to look it up in the docs. And under the implemented protocols, we've only got IEX.info and inspect. So unlike a list, we don't have a whole bunch of utilities for iterating over it or doing a reduce or a map, or any of those things. But what tuples do have is the property where they are set in memory contiguously, which means if you have a tuple with 10,000 items, you can very quickly go to item number 8,000. Whereas with a list, to go to item number 8,000, since the list items are not set together in memory, you would actually have to traverse all 8,000 items of that list from or before the item that you're going to. So it's very different performance characteristics. It's more expensive to copy them though, so it's closer to a binary. This is also a new thing, an atom, and an atom is basically anything that starts with a colon. So we can inspect the atom foo here, data type atom, reference module atom, and it's got a few more protocols. Atoms are similar to strings, but unlike strings, atoms are completely unique. So if you see the atom foo, you know there is only one foo, and there's never even a reason to compare the atom foo with the atom foo, because it's stored in one place in memory. It exists completely uniquely. There's also a limit to how many the VM can handle at the same time, so you don't want to have a program that's dynamically creating lots of atoms. Okay, so back to the docs actually. So we've got this tuple, the OK, the binary, the error, the reason, and these are the typical error reasons. They're not very clear to the end user. So what we're going to want to do is we're going to want to use this :file.format_error function. It's kind of weird that this function has a colon at the beginning. The reason for it is because it comes from Erlang. If we click through, we'll go to the Erlang documentation on it. This will happen to you every once in a while if you're working with Elixir, because Elixir is built on top of Erlang, and one of the perks is you can call Erlang functions and use Erlang from within Elixir. Okay, now our file.read, file name, and we're gonna use pattern matching on these tuples. So if it matches OK and something, which will be assigned to body, we will just return body. And if it matches error, reason, we'll capture the reason and send it to the user. Oops, there we go. io.put could not open file. And you know, we should actually name the file. So, all right, we'll use the sigil for quoting the string so that we don't have any problems with having quotes inside it. Could not open the file, quote, file name, close quote. So those quotes will actually show up in the string that's printed out to the user. And we end our string with the parenthesis. All right, and we'll put out another line saying, we'll just pass the error. We'll inspect the error, the reason for the error, sorry. And you know what, we also want to have a new line there so that this error comes out on 2 lines. And for right now, we'll just have start call read directly. Actually, no, we're going to get the file name from the user and then we'll call read. So file name equals io.get name of .csv to load, and we'll pass that to string.trim so that we don't get the enter that the user hits after typing in the name of the file. And then we call read file name. Okay, let's see what we got so far. So we'll compile minimal underscore todo .ex, and we got a bug. Missing terminator and for do starting at line 1. Def start do. I don't have an end for my case statement. There we go. Excellent. Minimal todo.start. Name of the CSV. Oh, right, we need a CSV. 1 second. Okay, this is Open Office. I've got a CSV here. 2 to-do items. Take out the trash and see the doctor. And the names of the headers here are the item name, priority, urgency, date added, and notes. Okay, so you notice I made one very high priority, low urgency, rather a low priority, high urgency. I've made number 1 highest urgency or highest priority, and the other being the reverse. Okay, save this, and now we should have a to-do CSV. Excellent, and as I said, it is kind of readable, even just in text. Okay, so we've got a to-do to load, todo.csv. Excellent. So loading reading the to-do just returned a string of everything. And you can see these \r \n. Those are the new lines. On some systems, that's just going to be \n, and on some really old ones, it's just \r, but on Windows, it's both. Let's see what happens if we enter a file name that doesn't exist. recompile, start ASDF. Could not open file ASDF, :eno.net. Yeah, that really is a pretty poor reason. So we'll use the elixir-lang function that we just looked at in the docs. It's a string, and should we quote it? Yeah, we'll quote it. And interpolate file dot format error reason, and we also want a \n so that we get a space afterwards. Oh, that's a bit odd. What happened there? We are escape. Oh, because I did IO inspect. That's what it is. IO.puts. Actually, gotta recompile. There we go. Excellent. Excellent. Okay. Now the next thing that we need to do is let's make the parse function. So to parse, we're going to read in. Well, we've already done the read. So the read is just a long string, aka binary. So the parse is going to read that and split it into lines. And then we need to get some data out of those lines. And then we need to, well, let's see, we need to get the header out, because the header is just the names of the columns, like priority or date added, that kind of thing. So the next thing we'd have to do is get that header separated out. Then we'll iterate through each individual line in order, and we'll be splitting that on commas because it's a comma separated value file, aka CSV. So it's quite a bit of parsing in this one. Def parse, and lines are going to be equal to string.split body. And you may recall there are 3 different ways that carriage returns, or that new lines are encoded. So we're going to make a regex that matches any one of those 3, /r /n, or it could be \r, or it could be \n if it's on a newer Unix machine. And that'll get us the lines. Okay, let's just return the lines for now so that we can look at it in IEX. Oh, that one's no good. You know what? If it gives us, if we have an invalid file name, we should just have it ask again. I should just call start. Okay. Yeah, that's right. Keep asking until we get a good answer. So we're going to type in the real one, and then we're going to use this parse. Now, one thing we can do if we're typing in minimal to do dot something again and again and again, we want to avoid all the typing, we can type in import minimal to do. When we do that, now everything from minimal to do is accessible right from the command line. So if I type start, it goes straight to a CSV. And similarly, I can do something like this. Let's see, I can get the body, read that in with read. So read todo.csv, and then I can just parse the body. All right, now let's talk a little bit about lists. So we've been using lists in these tutorials, but you might not know exactly how they're put together, and they're essentially linked lists. So if you just have one element, that's pretty straightforward. If you have another element this is actually structured like this. One, and then the other part of the cell that is in the first item has a 2, like so. And if we did that, that's the same thing as 1. So the 1 has, so this first cell has some information which is a 1, and it points to another location in memory, and that location in memory might be empty. If there's no data there, then that's the end of the list and we just have 1. But if there is data there, then that's the next element in the list, and this can go on and on and on. Like so. So this is useful when you're pattern matching. So we have parsed body. Let's put that into. Let me reload. Yeah, there we go. And now let's parse the body. Okay, so the lines equal the parsed body, and now that we have this lines looks like it's a list of 4 elements. We can match against that. We can pattern match against that, getting the header line and then say the items. That's what we could call the other lines. So we do have to use the equal sign though. So this equal sign is really powerful in Elixir. It's a matching operator. So it looks at the structure of lines, which is a list, and then it can actually break it apart and match header against the first element in it, and then items against everything else in it. So it's kind of like header grabbed this, and then lines grabbed that. Once you get used to it, you'll find this saves you a ton of time, and you'll be wishing other languages had it. All right, so we've got the header, we've got the lines. In both cases, we need to split these on commas, and that's no surprise at all. So let's go back to our program. So header equals, actually we'll set them both, header and items equal, you know, it's even easier, we can just do that up here. Header and the other lines equal string.split the body. All right, then the titles equal, okay, so the titles equal string.split on the header using the comma to do the splitting, since this is a comma separated value file, aka CSV. And we're going to use a function called tail, which kind of does the same thing we just did here. So look at lines. TL of lines gets everything but the head. HD of lines gets the head. HD does the same thing to a list as list.first or Enum.at 0 that we saw last time. TL gets everything else. Header, and we're going to do TL of that. Okay, let's give it a run. Reload minimal to do. Body, still got the body from before. I'm just, since all we changed is the parse, I'm just gonna run the new parse on it. Excellent. Those are the titles, and we do not have item in it. All right, that's what we want. That is exactly what we want. Then the last step is a little bit messy. Last thing is, or not the last step, but the other thing we need to do is we need to parse each line that we're getting. So each one of these. I'll just look at one. Well, I'm going to look at a different one. We'll look at the head of the tail of lines, which is the same thing as the second line. Let's take a stab at this one line at a time. So I'll just say a line equals this, and let's parse our line by splitting it by commas. Split string dot split comma. All right, so we've parsed that essentially, and we've got a name of the line, and we've got all the other stuff from the line. Enum has a really cool thing in it called zip. Enum.zip will let you combine two enums that are the same length and make them into a list of tuples. So one more thing to do here. Let's just take the tail of this because I removed the name of, I removed item from the headers. So just call it L. That's easier. Don't want to type so much. All right. So we've got L, and then we've got header, or we've got titles, and I don't have titles. Titles equals tail of string dot split header and comma separated. Okay, so now titles enum.count. Excellent. Enum.count lines. No, not lines. Excellent. Okay, so they're the same length. Now we can use enum.zip. Actually, let's do it the other way around. Titles L. Now that's looking kind of useful. Priority 4, urgency 1, date added, December 11, notes, it's really starting to stink. We could actually just use this structure to do everything. But instead of that, let's use a map. A map is pretty similar to a map in Ruby or say an object in JavaScript. It's got a whole bunch of keys and a whole bunch of values. So this is an empty map. And note that it is enumerable and collectible, just like lists are, which means useful utilities we can use on them. Maps are basically like this. You'll have some key, so some key, some value, and they don't all have to be the same kinds of keys and values. Like you could have just a number in one and a string in another. That's fine. So we'll set this to map. So my map has all that, and I could say map.sum key some value. All right. And maps are immutable. So this is a huge difference from JavaScript or Ruby. Pretty much everything in Elixir is immutable. So you can't just tack something onto a map. What you have to do is actually create another map. We can do that with map.merge. So we can map.merge our original map and then say this map where foo is equal to 32. And now we've got a map that has all of the keys from the previous one and the new one. There's also an update syntax, which is pretty useful, where you can update the value of one of the existing keys, like so. So notice we have the same things, but if we try to add another key to it, we get an error, because you can only update things that are already there. There's also a map.put, which will generate a new map with a new value in it. Like you can put another thing into the map. As usual, check the docs. We will mess around with maps quite a bit here though. So just a moment ago we were looking at enum.zip, and we could zip we could zip these two lists together into a list of tuples. There's another function called enum.into that we can chain on to enum.zip, like so. And now we have a map that has all of these things. And that's kind of neat. So the value of date added in this map is December 11. So we'll say, we'll just call this data for now. So we can say data dot notes. Oh, we can't do the dot notes because it isn't an atom. The dot syntax only works with atoms. But we can do that. So the next thing we're going to want to do is set all of this stuff to the name of the item. And after we do that, we're going to want to reduce all of the lines one by one and build up a map from the information we're getting from the lines. This is a bit dense, so just bear with me and we'll build the function, and then you can play around with it and figure it out. Lines and titles, and I'm going to start with enum.reduce. Enum.reduce. Reduce, you know what, it's complicated enough. I'll just show you a simple example here. So make a list of numbers, say 5, 7, 9. We can use enum.reduce to reduce this collection into a single item, and the way you do it is you pass enum.reduce either 2 or 3 parameters. The first parameter is the list, or the enumerable thing. It doesn't have to be a list. Second parameter, if you only have 2 parameters, is the function. And this function takes 2 arguments, a and b, we'll call them, and then the function has to return what to do with a and b. So in this case, we'll just add them. And after this function is executed on the first 2 elements, whatever this function returns will become one of these arguments, and the function will be executed on the return value of the function running the first time on the next element. And then the return value of that will get executed on the next element, and so on and so on. So here, this function just adds them. So 5 plus 7 plus 9 is 21, and we could make it so that it multiplies them. And 315 looks about right. All right, so enum.reduce is useful when you've got a whole bunch of things and you want to build one thing out of all of them. In this case, what we're going to do is we're going to read in a whole bunch of lines, and we're going to build a map out of all of them. And each time we're going to use map.merge on what we have so far with the new data from the line. The line, we're basically going to be taking this approach with each line, and we're going to be sticking that data under a key that is the name of the to-do. So we reduce the lines. You can also pass reduce a third parameter, and the third parameter is the initial value. So in this case, if I gave it another parameter of 1 here, we're going to have the exact same result, because we just have 1 times the first value, then the result of that will be times the next value, and then the next. But if I made the initial parameter say 0, we'll have 0, because we'll have 0 times a number, which is 0, times the next number, which is still 0, times the next number, which is still 0, and so on. Okay, so we're starting with an empty map, and then our function is going to have 2 parameters, and just to make it clear what's going on, I'm going to call one of them line. It's the current line we're processing, and the other we'll call built. And this is the map that has been built so far. And we definitely need more than 1 line for this. Okay, we're going to pull the name and the fields out of the line. Actually, we've got to split the line too. And we're splitting by comma, of course. Okay, so that name should be take out the trash, and fields should be an array of everything else after that. Then I remember there was 1 empty line, so we don't want to do anything if there's an empty line. So we'll use an if. So if enum.count fields equals enum.count titles, we can do all the zipping and the other stuff. Otherwise, we're just going to pass what's already been built so far, essentially skipping that item. Okay, the next thing to do is to do the zip and the enum into, as we did here, and that'll be the line data, which is like this. Data equals enum.zip titles fields enum.into built, into a new map. And then after we have that, we'll map.merge what's been built so far with the name that we pulled out from the first part of the line. And the name will point to all the line data. Okay, this looks right, but this is a pretty, so we've got to close the end, and we need to close the parentheses. This is a pretty hairy function, so it'll be a miracle if this works. Let's see, undefined function, items. Oh, I call them lines. Okay, let's try again. So to enum, it's a typo, all right. It's not too bad so far. Reloaded. All right, let's see if it works. Do we still have the body? I still do. All right, parse body. All right, that's exactly what we wanted. So C doctor is the name of one to do, and it has all this info in it. Take out trash is the name of another. Okay, so we'll call this parsed data equals that, and parsed data dot, or not dot because it's quoted, C doctor. Oh my goodness, isn't that nice? that is pretty much usable. Now that that's done, we're going to use that parse data all over the place. So let's make a function to show the to-dos that we already have based on the parse data. We'll just call it show to-dos. Parsed data. We'll just say data. I don't want to type in parse data all the time. And after we show to-dos, we're probably going to want to ask the user what they want to do next. So I'll make a parameter called get, called next. Just say next command, and the default for it will be true. So that means if you call this function with just one parameter, then the value of next command will be true. Okay, the items equal map.keys of the data. I can show you this really quickly. So parsed data, yep, and map.keys of parsed data is just the keys. Pretty useful. So the items are map.keys of data, io.puts. You have the following two L's, or two L's following to-dos. Enum.each items function item io.puts item end. All right, and io.puts another empty line afterwards, just so that we have some space before the next thing. And then if get next command, we're going to call the, or if next command, we'll call get next command. And we'll pass the data. We're going to have to pass that data all over the place since everything is immutable. And we should have a function for get command. We're just going to make a really simple one, like one that does nothing for now. Data, we'll just echo the data. Okay. Let's see if the show to-dos works. And that is because, but I forgot a do. Yep, I did. I forgot a do. Should have used my snippet. Okay, let's give that a try. I think everything should be. No, what is next command is unused. That's just a warning. Undefined function next command. Oh, another typo. Okay. Here we go. Okay, now it loads. Parse it. Okay, so body equals read. Like, did I don't remember if I did or not, so I'm going to import the module. Just so that we can get everything. Okay, so we're going to read todo.csv, and we're going to pass that data into parse. We're going to save it. Okay, we'll just do this one step at a time. Okay, so we'll read in the file and put the contents in the body. Read todo.csv, and then we're going to parse the body. Very good. Set that to data. And then we'll see if we can show to-dos from the data. see doctor take out trash. All right, that one looks pretty good. All right, and we kind of want to do all of this automatically when we start. So we read the file name and start. There's no reason we couldn't just use a pipeline and send that data we get straight into parse. And then once we've parsed in the data, we can send that to get command. And get command. And in get command, we're going to have the data at our disposal so we can pass it to the function for whatever we're going to do next. We're going to have to ask the user to put in some input. Let's see, we have a longer prompt, so I'm just going to put all the prompt that we're going to ask them with io.gets into a string. Type the equals type the first letter of the command you want to run, and then we will append another line to that. Actually, there should be 2 lines. Let me add a new line there, and we'll append read Todos. So they type in the R to get to make that command happen. 1, 2, 3, 4. Probably enough space. Load .csv. Add to do. This is kind of a random order. Let's see. We'll make read the first option, then we'll add, and then delete. 1, 2, 3, 4. Delete. To do. Load .csv. And save .csv. All right. Is that line too long? I think we're okay. It's 89 characters. Now it's 85 characters. But it's okay. We can just use a here doc syntax, and then there's plenty of room. And now we don't need a /ns or those quotes. 77 characters. All right. All right, so we've got the prompt. Then we need to get a command from io.gets. We'll just pass this prompt in there. And we want a string.trim because there's always a return that comes in. And I'm using this kind of formatting just because we've got a couple things to do. String.downcase. This is exactly the same as if we did something like this, but I think it's easier to read if we put the pipelines just in a straight line like that, and it's pretty common to see in the Elixir community. Okay, now we got to do something with these commands, so we'll use a case statement. And the reason we've done the string.downcase above is so if someone types in a lowercase r, you can still read the Todos. I think that's just reasonable. So get an R. We will read the Todos. And in order to read them, we need to pass the data. And after we're done reading them, by default, we get the next command. See, show Todos. Oh, it's called show Todos. I have to change that. If we didn't pass a second parameter to it, we will call get command right afterwards. And I think that's reasonable, because you say you want to read them, then you still have to decide what to do. So show Todos. You know what? we've already gone pretty long here. I think we're gonna have to break this into multiple parts. So this video, we're just gonna implement delete, and actually also quit and a wildcard. So D will be delete to-dos. We gotta pass the data, and Q is just gonna quit. And so to quit, we'll say goodbye, and then we'll have a wildcard. So if somebody puts in any input that's invalid, we'll just call get command with the data again. So it'll just keep on listing the commands until they do something reasonable. Okay. So we need to make a delete to-do function. Delete to-do, and we take in data as usual. First thing we're going to have to do is ask what to-do the user would like to delete. So we'll set io.getString to, we'll have it prompt the user with which to-do would you like to delete. New line, and we'll trim the new line off the input. Then we've got to check and see if it exists or not. So there is something in a map called hasKey. It's much like map.keys will get all the keys that exist. If we use map.hasKey, it will just return true or false based on whether a key exists or not. So our data is one big map, remember, and the to-do might be one of the keys of the map, because all the keys of the map are the items, the to-do items. So if they typed something that was a key, then if map.hasKey will return true. And then what we want to do is we want to say okay, and then we want to drop it from the map. Map.drop just drops all the key values that correspond to a list of keys that you give it. So it's actually for dropping lots of things, but in this case we only want to drop one thing. So data, and we put the single to-do in a list by itself, since this function requires a list. And then after we dropped it, we'll tell the user it's been deleted. Actually, we have to save this. We have to capture the return value of this map.drop, because maps are immutable, just like everything else in Elixir. So it's not like Ruby where we can just mutate the map as we go through. We can only get a new map that doesn't have things the old map had in it. So new map equals that, and then we're going to tell the user we'll tell the user it has been deleted. To do has been deleted, and we don't want to quote there, we want to quote here. I hear fireworks outside. Hopefully they're not too loud on the recording. All right, then else means the key doesn't exist in the map, which means there is no to-do with that name. There is no to-do named to-do. And we want quotes here, I think. And that means we need a sigil. I'll use parens. Actually, use parens on both of these because we have curly braces inside, even though they're not matching. If we had a, it's just a little bit clearer this way. All right, so there is no to-do named to-do, exclamation point. Then if we couldn't delete the to-do, we should show what to-dos are there because the person just typed in something that wasn't there. So we'll show to-dos. Sorry, it's called data, not parse data. False. This false is so that the show to-dos doesn't automatically call get command. Because if we just try to delete a to-do and we mistyped it, what we want is to see what the to-dos are and then have a chance to type it correctly instead of just have to go through the command screen again. So we will call delete to-do. Data. And in the case that we did delete it, then we actually do want to get command with the new data or with the new map. Okay, let's see how this holds up. Missing terminator end, didn't end the else. Didn't end the case. Undefined function delete to do's because it's just delete to do. Okay. Get commands, same problem. Okay. Minimal todo.start, todo.csv. Let's read the to-dos, see the doctor, take out the trash. Let's add one that doesn't exist yet. That's good. Empty input, good. We'll delete one. I would like to delete the do homework to-do. Oh, there isn't one. There is no to-do named do homework. You have the following to-dos. See the doctor, take out the trash. Which you'd like to delete. I'd like to delete see doctor. Okay, see doctor has been deleted. Let's read the to-dos. It has been deleted. Let's delete another one. Take out trash. Deleted them all. All right, I guess all we can do now is quit. Let's do a quick recap. Today we encountered maps and manipulated them a bit. We saw some more functions in the enum module, or I should say protocol. We looked at lists and what their structure really looks like. We did pattern matching assignment. We did a whole lot of manipulation of data so we could parse a CSV. And we've also made a basic CLI for a really weird to-do app. Next time, we're going to implement the missing features like adding to-dos and loading a file, which is kind of already done in read here, saving a CSV, and possibly a more detailed display, because right now we're not showing anything for the to-dos except their name. So maybe we can display all the priority and other information in the to-dos. And I have a challenge for you today. Take a look at the Elixir docs for the file module and see if you can make a program that looks at all the file names of the current directory and moves the image files into a new directory. So you'll have some directory with a whole bunch of files in it. You'll have to look at them, and then based on the file name endings, like say if it's .jpg or .bmp or .gif, just pick a few common ones that you actually have on your computer. Then make a new directory called images and move all of those image files to the images directory. I recommend you make a backup directory, like just make a new directory. Be careful because you don't want to accidentally delete all your files if you don't have them anywhere else. So give it a shot, and next lesson we will continue with the minimal to do. And until then, happy coding.